Take out your notes, please.
How's Alexa doing the camera?
We are talking about fractions with variables. Let's see if that's actually on screen. It is. What have we got? Okay. Fractions with variables. Now, just as a quick review, if we did fractions without variables, for example, 12 over 16, can somebody reduce that for me? What's 12 over 16? Go.
3 over 4.
Good. What number goes into both of them? 4. So you divide top and bottom by 4, and you have 3 over 4. Does that make sense? You can also do that with variables. 5x over 15x. Can somebody reduce that for me? Right here. Yeah, it's x over 3x, and interestingly enough, you can reduce it one more time. Technically, what's in front of the x? 1. What does that reduce to? 1 over 3, because the x's cancel. In the same way that you can divide top and bottom by 5, you can also divide top and bottom by x. Does that make sense? So you can cancel not only numbers, but variables. Now, here's where there's a little bit of a surprise. We have been doing, I'm going to do this as another review problem. See who remembers how to do this. X plus 4 dividing into, let me see. Do it for me. Who can start me off? It's a long division problem. There's a binomial dividing into a 4-term thingy. They don't have a special name for that. A tetranomial. Where do you start? This is from 2 chapters ago. How do you do long division? Where do you start? Go. Thanks.
See how many times, see how many times x plus 4 goes into x cubed plus 5x squared.
Technically, yes, although there's a step. You're so good at this, you skipped a particular step because it was impossible. Easy.
You add 0 above x cubed because x plus 4 can't go into x.
Right, a 2-digit number can't go into a 1-digit number, so it's going to be a 0 up here. So, plus what? So now, once it actually works, how do you actually get this thing to start running? Because now it's a little complicated. 2 digits go into 2 digits, that's good, but is it x going to x cubed, x going to 5x squared, 4 going to this, 4 going to this? Which one goes with which? What do you look at? Just 2 terms. What goes into what? Good.
X goes into x cubed.
Yeah, the first term into the first term. That's all you look at. That's the only thing you look at with long division. Can somebody tell me, how many times does x go into x cubed? Titus.
I don't know.
You remember? Go. I don't know either. Let's find out. How many times does x go into x cubed? You might be surprised. I'm not just doing this to be silly. Do x cubed over x. Tell me what you actually get though. Go.
Squared.
X squared. Isn't that a surprise? It looks like it might be 3, but it's not. X would go into 3x 3 times, but not x cubed. So up here you put x squared. It goes in x squared times, which sounds odd, but there it is. What do you do with it? when you get it up there. What do you do with the x squared? Joe?
Multiply it by 4.
Yeah, what's x squared times 4?
4x squared.
Put it under here. And then plus, and then you have to do what? X squared times x is what? X to the third. Put it down here. So you multiply. It's just like regular long division. Yeah.
How did you get the x squared from the problem over there?
Okay. I want to know how many times x goes into x cubed. Whenever I say how many times does something go into something, is that an addition, subtraction, multiplication, or division problem? It's division. So how many times does 2 go into 10? If I say 2 goes into 10, yeah, how do you get that?
Dividing.
Yeah, in your head, you did what divided by what?
You divide by 10. Or 10 by 10.
Yeah, you put 10 on top. Does that make sense? That's what we did over here. How many times does x go into x cubed? My answer is I don't know. Let's do it. X cubed over x. And then technically, that's really x times x times x over x. And then one of the x's cancels. You know that to the x squared. Okay? So, congratulations, you just multiplied, got the row. What do you do with that row? Elijah, what do you do with this row?
You add the opposite.
Ah! Normally we subtract. I hate subtraction. I like adding the opposite. But there are two opposites. Add the opposite. Do it for me. Elijah, go. What is this going to be?
Is 0.
0. And then what's this? 5x squared minus 4x squared is 1x squared. We are done with the first cycle. Can somebody do the second cycle for me? John.
See how many times 1x goes into x.
True, although I'd bring down the 4x first. But yeah. How many times does x go into 1x squared? I don't know either. Let's find out. 1x squared over x gives you what? Go ahead. Yeah, 1x, or just x. Put that up here, plus 1x. What do you do with that? Let me see. Olivia, take over.
So you multiply, or wait.
You're right, by the
You
way.
multiply x times 1x.
Okay, and get what?
Put that under the 1x squared, and then you would multiply 1x times 4.
And get what?
Put it under the 4x, and then you would normally subtract, but in this case we're gonna add the opposite, so it's
Nice.
gonna be plus negative x2 negative x. or
Nice, negative 4x. What do you get? 0? And by the way, that's insanely lucky. We normally do, I know, that I apparently say that a lot. But it gets 0x plus, that was from pre-calc. I had designed a bunch of problems that came out nicely with like non-fractions. And I would always say like, this isn't, you have no idea, you are so lucky. Like in real life, you're gonna get a fraction as an answer, honest. And then 10 times in a row, we got a whole number. And then they said, yeah, you're lucky, you're so lucky. It's kind of like what we did in here for don't get used to it. It's kind of the same sort of thing. Anyway, 0x plus 0. Can somebody tell me how many times, Sarah, take over. How many times does x go into 0x?
0.
Yeah, that's actually a good point. I don't know, let's find out. The x's cancel and it's 0. Plus 0. All right, now I'll even do the multiplication for you. Woohoo. 0x plus 0. And guess what? Add the opposite. This is a math joke, by the way. Negative 0 is good. So I did that with the first year algebra that I taught in a previous school. They would do the square root of 0. I said, what's the square root of 0? It's 0. I said, or negative 0. And they would like, wait a minute, isn't that the same as 0? Okay, yeah, you got me. But it's 0.
Good save.
What's the remainder? The remainder is 0. That's incredibly lucky, by the way. You are so lucky.
We are so lucky.
Now, we're done with the problem. I got this, and I get this. Now, why did I drag you through this? Please write this down. Simplify. X cubed plus 5x squared plus 4x over x plus 4. Go ahead and write that down. As a quick review, you don't have to write this down unless you want to. And this is especially for the people who were not here before. Let me just quick write this and I'll get your question. So x plus 4 over 4. True or false? Can I do this? Cancel the 4's and get x? No. What's stopping us? Elijah?
The addition sign?
The addition sign. Did I give you my addition sign speech?
No.
It wasn't the I hate subtraction speech, it's different. Okay. I do not recommend the movie necessarily, but it was an old movie, it was in the 80s called Gremlins.
Yeah.
Okay, it's not, I'm not endorsing it, it's this weird movie where there's these cute little fuzz balls that came from space or something. And you, oh, sorry, they came up here. Sorry. What? Oh, fine. Hi, everybody at home. Yes. So, I just realized I'm talking to the video about a movie, Gremlins. They have all the evidence they wanted to fire me after this. But anyway, I'm in it now. So there's these cute little furry fuzz balls, you know, like cute little ears, you know, adorable. They look like teddy bears that walk around. And they're fuzzy, they're cute, they're friendly, and apparently there are two things. And it's a movie, so it's a stupid premise. So don't get them wet, and don't feed them after midnight. If you get them wet, they like multiply. They get 1 turns into like 20. And if you feed them after midnight, they turn into these really creepy bat-like things that tear up the house and cause all sorts of mayhem and chase people around and terrorize people. So the moral of that story is, what is aside from counting, what is the first math operation we ever learned? Addition. It's like addition. I remember addition. Wasn't it nice when all we had to do was add 3 plus 2 or something like that? Oh, addition. I've known addition since before kindergarten. It would never betray me. It would never hurt me. It's a cute little fuzzball. It's just, oh really? I'll never hurt anybody. I'm just this cute little addition fuzzball. Wrong. The thing just bit your face off when you weren't looking. So addition, let me show you another one where it doesn't work. X plus 2 parentheses squared. Is this x squared plus 2 squared? Look again. This is what's called a binomial squared. There's a 3-step pattern for a binomial squared. Square the first, double the product, square the last. What should this be? X squared plus 4x plus 4. In other words, this didn't work. And guess what caused the problem? This cute little plus sign. If that had been a multiplication sign, it would have worked like a charm. Watch this. X times 2 squared is x squared times 2 squared. That one works wonderfully. Multiplication is fine. Cute little addition. You can trust me. I needed facial expression. You can trust me. No, you can't. Because it's about to devour you when you turn your back. Addition actually despoils every exponent rule in the book. Every single exponent rule crashes, burns, and dies when you put a plus sign in the middle of it. It's really awkward. So, the reason I went to the big fuss on that is, look over here. Can I cancel this 4 and this 4? No. What's stopping me? Plus sign, and another plus sign, and another plus sign. The short answer is that division does not cancel addition. Division cancels multiplication. So you cannot cancel this isolated part from this isolated part. So it looks horrible. We would have to do long division in order to do this problem. Or do we? I need my facial expression back. Or do we?
Beware expression is right. It's up there. Third one.
Beware when the mathematician grins. Now, let me show you. Does anybody see what we might be able to do? Yeah. Or the question or answer?
I have a question.
Yeah, go for
Wouldn't
it.
it just equal the same thing as the review problem that we just did?
As a matter of fact, it would. I'm just curious. Yeah, by the way, I could put equals x squared plus 1x. I can even ignore the 0. And I'd be done. Why? Because we did all this brutal work over here. But I want to show you something else. I want this to be dramatic. Look at the top, and for my own mysterious reasons, can somebody factor the top for me? Go. There's a GCF of x. What's left behind?
X squared plus 5 x.
You're going to like this, trust me.
4.
Plus 4. All over x plus 4. Question, does that parentheses factor again? That is. It unfoils to what two parentheses? X plus 1, x plus 4. Let me do a little favor for you. I want to wrap the bottom in parentheses. Does anybody see something interesting that's about to happen? Cece.
You can cancel the x plus 4.
Bam!
Yes.
Simplify for me.
No.
What do you get? X squared plus?
X.
Really?
Really?
That's cool.
In about 1/5 the time.
Oh, that's fine.
Factoring is your friend. Factoring is going to come in so handy. That's why I fussed about factoring for an entire chapter. So what does it have to do with this section? Fractions with variables? A lot. If you can factor, you may be able to save yourself a lot of long division problems. There are some problems where we have no choice. We have to do long division. But those are the ones that don't factor. If they do factor, you can probably cancel something. We can get unlucky, yes. There are unlucky days always. But let me show you another example. Let me see. Let's make this fun. Let me see. Yeah, how about this? X cubed plus 5x squared minus 4x minus 20 all over, let me see. Okay. X squared plus 7x plus 10. I would like you to reduce this. Now this, we would normally do a long division problem. That is a very big long division problem. It's got 3 terms going into a 4 term. We did one of those on the test in chapter 9, by the way. But I'm just curious. Does anything factor? He asked with a slight quirk of his own. Go.
The bottom.
The bottom factors into what method?
The unfoil.
Unfoil. What two numbers add up to 7 and multiplied to be 10?
5 and 2.
Yeah. So x plus 5, x plus 2. I'm going to rewrite that. X plus 5, x plus 2. That was a horrible 5. Hang on. 5. That's better. Well, math people, does the... I'm getting all right, fine. I'm just a creature of habit. Does the top factor? Go on.
Yes, by factor by group.
Factor by grouping. I'm going to add the opposite just because I'm me. If I factor by grouping, does that first pair have a little miniature GCF? It's easy.
X squared.
X squared, what's left behind?
X plus 5.
X plus 5. Is there a mini GCF in the other one?
Negative 4.
Right. If it starts negative, hold a negative. And then what's left behind?
1x plus 5.
Yeah, x plus 5. Question, is this going to work? Is factoring by grouping going to work here? Tell me why you're saying yes. Go. Parentheses are the same. That's a common factor. Pull it out in front. We now have, in front is x plus 5, and behind is x squared minus 4. That was a little strange to me. I took x squared plus negative 4 and wrote it as x squared minus 4. Why would I do that? He asked, asking himself. I have x plus 5, and then, does this look familiar to anybody? Yeah, Reagan. Difference of two squares. What does it split into? X plus 2, x minus 2. Then, oh, a bunch of little miniature humans walk by. And then x plus 5, x plus 2. They're good. Let's see. Now, back to math for a second. Does anybody notice anything? Yeah.
Okay, we have two common thingies. But because it would be x plus 2 and x plus 5, so cancel all.
Cancel, cancel. Your final answer is what? Done. Does that make sense? If you can factor, you can save yourself a lot of long division problems. Not all of them. Into every life, a little long division must fall. But you will save yourself a lot of long division. That's bonus number 1. Now, bonus number 2. This is where things get a teeny bit more involved. I'm curious if you remember how to do this. This was back last Friday, I think. How do you do that? Yeah, like.
Don't you do crisscross
Crisscross across. What does that mean?
It's when
Elijah, keep going.
curse
How do you do that?
1 times y.
1 times y is what?
1 y.
1y. Where do you put that? Top or bottom? Top. The diagonals go on top. And then there's a plus. Plus what? Keep going.
2x.
2x. Crisscross. Then what do you put on the bottom?
X should be 1. So x, y.
You're done. Yeah, gotcha. Yeah, go ahead. Does that make sense? This works with numbers and with letters. Just as a review. 2 over 3 plus 4 over 5. The one disadvantage of crisscross across is it doesn't reduce for you. You might have to reduce. Yeah.
And you can do it like, switch to like 2x plus 1y or?
Yes. Yeah, the criss and cross, whichever was on top, that's fine. There's a rule in geometry. There's a rule in algebra that says, it's called the commutative property. That means if you add it one way, it's the same as 2 plus 3 is the same as 3 plus 2. So yeah, so addition is safe to do that, flip around. Can somebody do this for me? Go, Reagan.
So 2 times 5.
Uh-huh.
Put that on top.
Go ahead and do that. 10 plus
4 times 3, which is 12.
12, all over.
3 times 5 is 15.
Summarize, simplify.
22 over 3.
There you go. And again, in algebra and beyond, you have my permission not to switch it to a mixed number. If you want to, it's fine. So like saying, how many times does 15 go into 22? Does anybody know off the top of their head?
1.
Once. How much is left over?
7.
1 and 7 15ths, which is okay. But I prefer this. The reason, it's not just because of my preferences. In algebra, there's a notorious habit of multi-part problems. So what might happen is, people will say, okay, part A, add 2/3 plus 4/5. Ta-da. Then they're going to say, now multiply it by 3. Which one's easier to multiply by 3? The fraction or the mixed number? Fraction. You have to change it to a fraction anyway to multiply or add anything. When you're still doing math, this is the easiest one to do. When you're all done, switch it over. Why do we have mixed numbers? I'll tell you why we have mixed numbers. For the poor slobs who are working at Menards or Lowe's or something, and you walk into the store and you say, hi, I'd like 23/4 feet of lumber, please. And they say, what? And you say, well, I'd like 23/4 feet of lumber, please. And they're going to look at you like you have 3 heads. They say, what is that? I said, seriously, you work at Menards and you can't figure this. So this is for the poor souls who are working there. 4 goes into 23, that's it, 5 times? With 3 left over. 5 and 3/4. Is it 5 and 3/4 feet a little bit? Oh. Yeah, see? So this is for people on the street. Mixed numbers are for people on the street, or if you want to figure out sort of how big a number is, mixed numbers are decent. But as far as out, as far as math goes, as far as numbers go, I would like you to leave it like this.
Here, while we're down the hall.
Yeah, go.
Where'd you get the 15?
Where do you get the 15? Oh, 3 times 5.
Oh.
Yeah, so multiply. The 2 diagonal multiplies go on top, and then the across multiply goes on the bottom. Yeah, Max. Yes, survey. Everybody okay so far? Yeah.
So crisscross across is only for addition.
It's only for addition and subtraction, because that's just addition backwards. Yeah, Joanna.
So you don't have to change it into a
Correct. In my class, you do not have to, unless I specifically tell you, and that'd be like, once in a blue moon, really rare, then you do not have to switch it to a mixed number. Correct. Again, is it ever useful? Yeah, I suppose. If you want to graph it on a number line or something, then even then I kind of cheat, but it's okay. But you are not required to switch it to a number line, correct? Now, try this. 7 over 12 plus 5 over 24. Can somebody tell me how to do that? I'm adding fractions, which means I'm going to need a what? Let me see. What am I going to need in order to add to any 2 fractions? Common denominator. Can you tell me a good common denominator for this one? What's that? 24. How do you get that? I mean, it's a neat skill to have, but there has to be a technique. Like, what did your brain do to get the number 24? Yeah.
You see, that is 12, 24,
Yeah. In other words, I want a number that's big enough to hold 12 and 24 at the same time, but not too big. Too big means that I have a lot of reducing to do, which doesn't kill you, but it's waste time. 24 works. Let me show, yeah.
Which one is this one called?
This is just a review problem for, I'm adding fractions, but I'm soon going to show you why factoring is going to come in handy. How did I get 24? Well, does everybody, I'll even show you a little bit of shortcut. Yeah.
I was gonna say you're going to like 12, like 2, and then like past it.
Oh yeah, we're going to do it in a minute. But I said, I'm still trying to figure out where the 24 came from. Go. So yeah, go on.
Because 12 goes into 24 twice.
Correct. Now, here's what we did yesterday. Can somebody factor 12 for me? Go, Susie. 6 times 2. Does that factor anymore? 3 times 2 times 2. Did everybody agree? So this comes from here. How about 24? Let me see. Right, okay. Let's factor 24 for me. 12 times 2. Is anything else split?
12 is
6 times 2 times 2.
which is 3 times 2 times 2 times 2.
So 12 is really 3 times 2 times 2. And 24 is really 3 times 2 times 2 times 2. Pretend that these are people on sports teams. Yeah.
Sally 1, Sally 2, Sally 3.
Okay. Let's just say, you notice there are 3 different 2's on here. This is sort of like Sally Smith, Sally Anderson, Sally, Brickmaker. Yeah.
You forgot Jill.
But do you see the idea? Those 3 2's got to be different people. They all have the same first name. That doesn't mean they're the same person. This is not a duplicate. Like there are plenty of, I have a first name, honestly, Brian. There are plenty of Brians in the world. They're not all me. Although you want to hear something creepy, there is a Brian Conklin in Boston who's actually a cousin of mine who plays basketball. I know.
Boston.
Right. The fact that somebody has the same name doesn't mean they're the same person. Does everybody agree? There's 1 3. This is like Linda, you know, Linda, and then Sally 1 and Sally 2.
It's Jill.
Whatever. I'm just making them up as I go. Now, does it make sense that this thing, now, let's just say this is like the softball team and this is like the girls' basketball team. Is it possible for one human being to be on both teams at the same time?
Yeah.
Yes, it is. As long as they don't play at the exact same time, at the exact same place. So, this, guess who this 3 is?
Jill.
Okay, whatever name it was.
Linda.
Do you see it's the same, it has to be the same person?
Yes.
It's the first 3. This first 2 is the same person as this.
Sally.
This is the second 2. Who's this?
Sally Anderson. Sally.
This is yet a third.
Sally Hansen. I make bricks.
Okay, now clarify. Look up here. And let's not horse around with the calculators, gentlemen. Clear it, please. Turn it off.
He's using his own.
You don't need it. You do not need it. Now, look over here. How many people, quote unquote, were ever mentioned? Total. Yo.
7?
There are some duplicates in there though.
Wait. Like 1, 2, 4.
Is that your final answer?
7. Yes.
I don't want to count the same person twice. It's sort of like, if I invite all of these people to the sports banquet at the end of the year, listen up for a second. If I want to invite all of these people to the sports banquet at the end of the year, how many tickets do I have to buy? Go. 4. The 3 2s and the 1 3. Because these 3 were on the other team as well. They're duplicates. They're the same people here, but there's an extra person here. There's a total of 4 people. That's your common denominator. 3 times 2 times 2 times 2 is the common denominator you're looking for. Why did I mention that? Because factoring can help you find the best common denominator. Go.
Do we have to use that method to find it?
Short answer is yes, but the long answer is you can do if it's easy, you can do it in your head.
Yes, is long.
But I will warn you, there are some problems that are not, repeat, not going to be easy. Let me show you. I'm going to show you another way to do that same problem that's a little faster. 7 over 12 plus 5 over 24. Nothing says you absolutely have to factor it all the way. This is 12 times 2. Try that as the banquet by these. There's a 12, the same 12, and a 2. How many people are going to the banquet? 2. 12 times 2.
That's Linda.
I don't know who this is, but it's 3 people fused into 1, so it's very confusing. So, do you see how I got that? You see how I got the 24? Alrighty. I'm going to try a more involved one. That was this. How do you get the 24? I want a number that's big enough so that 12 goes into it and 24 goes into it. If you can do it in your head, great. But if you can't, break them into pieces and then do the how many people am I inviting to the banquet question. Whatever names you want. I don't want to get into the weeds there.
Linda is 12.
All right. Let's not go off track.
Jill is 3.
Ladies and gentlemen, enough rabbit trails. Back for, that means where you go off into the weeds and off the main path. Try this. Can somebody tell me the best common denominator for this one? Go.
4, 7.
What should I put on the bottom?
Oh.
77. Now, how do I get that? I need a number big enough to hold 11 and 77. And if you notice, this is 11 times 7. The 11 is already covered. I also need to cover the 7. That's where the 77 came from. Why am I making such a fuss over factoring when you can just do it in your head? Let me show you. Now we finally get the moment of truth. 2 over x plus 5 over x squared. Can somebody tell me a common denominator for that? Go. X squared. X cubed would have worked, but x squared is better. How do we know? Because x squared is x times x. This is x1, x2, x1. 2 people are invited. That makes x squared. That kind of make sense? Max? Okay, yeah, it's easy. Let's actually do this problem. What belongs up here? Good. Right. Yeah, because in order to get this up to x squared, I have to multiply by x, but you have to do the same thing to both sides, or both parts. 2x, and then this stays the same. Can anybody tell me the actual answer on this? They're not like terms, so be careful. You just put them next to each other. What's it all over? All over what?
X squared.
Yeah. X squared. What's the new top though? Go. Make it.
Would it be 2x plus 5?
Exactly, and that's all you do. You did. Oh.
What is that thing that circles?
Oh, that's x1 times x2. I was just keeping track of how many x's were there. I factored it so that I could find the individual people, the players, so to speak. Yeah, Susie.
So if you're multiplying x and x squared, wouldn't you add the exponent?
If you multiplied x and x squared, you get x cubed.
Okay.
Right, I did not. X cubed is actually too big. It would be a little like 77 times 11. You'd get some huge number, I don't know what it is, but it would be way bigger than you need. I kept it smaller. Let me show you another one, which is, they're not going to be in this homework, but in the next homework. Try this. 1 over x plus 2 plus 1 over x plus 3. Can somebody do that? John. You can do crisscross across. I would suggest, though, that you put these in parentheses. Okay, there's a cat there in my
So
phone.
is it?
Yep. So what's 1 times this thingy?
Parentheses x plus 3.
Yeah, parentheses x plus 3. Plus, what's 1 times this thingy?
Parentheses x plus 2.
And then what's this times this? That, if you remember, is called a FOIL problem. FOIL it for me. Actually, right now, I'll just show you where it came from. X plus 2, x plus 3. We'll FOIL it in a minute. But can you simplify the top for me first? There's a little simplification that happens. Good. You don't FOIL because it's not multiplying, it's adding. You add the,
Does that say plus?
that's plus.
Okay.
Yeah, that's a horrible plus sign. But
Would you do x? Yeah, x. Or sorry, 2x
ah,
plus 5.
2x plus 5 over, now somebody multiply this. By the way, the reason I hesitated to multiply the bottom, whoa, what am I doing? Sometimes we get lucky and something cancels. That's like 10% of the time. Did anything cancel here or no? Is there an x plus 3 on top? No. Is there an x plus 2 on top? No. Then we'll just go ahead and do it. So 2x plus 5 over what? Go ahead and FOIL it. Yeah, right.
X squared plus 5x plus 6.
X squared plus 5x plus 6. And that's it. You in the hang of that? Yeah, that's as far as I'm going to push it now. Open your books, please. Take your books out first. Open your books, please, to page, we're on 11B as in Jaeger. Page 432. Well, 433 is where it starts. Number 2, oh, there's number 2, okay. What's on page 432? Add, subtract, multiply, and divide. Beware. 2D looks like a long division problem. It could be, but it doesn't have to be. Hint, quick.
Oh, yeah.
2D, I will say no more. You can do it by long division, it will work. But there is a shortcut that I might possibly have shown people earlier in the hour. Number 2D, I'm just giving you a hint for 2D. It's a division problem, and it looks like a long division problem, but there is another way to do it. You are correct. Number 2C is multiplication.
I mean, like, the thing with adding, see, it's x squared plus negative.
What's negative 1x? Yeah. Max. I'm sorry? 2C, it's multiply the first thing by the second thing. I would stack multiply those.
We got 2.
No, we're glancing over 2. I'm giving some hints. Number 2A, you add, which means you add the like terms. That's all. 2B, subtract. That means add the opposites of those. 2C, multiply them. I would stack multiply. 2D, right, okay, question.
How can we do something like this earlier? Because it's not x squared is
Well, I will give you a tiny hint. Does x squared minus x minus 2 factor? I'll leave it at that. I'm not saying. Now, the next page, just so you know, look at number 4A. Number 4A. The denominator of a fraction cannot be allowed to be 0. Any idea why? Why can't the bottom of a fraction be 0? Go. Can't divide by 0. 0 can be on top, that's fine. 0 cannot be in the bottom. Oh, sorry, people who are listening at home. Maybe I should just rotate it over here. I might be still on screen. I completely forgot about the people at home. Sorry. So, I'm actually going to post this on YouTube, believe it or not. I've got 1 subscriber. Yay.
I'll subtract you.
It was it's if you do a search for Brian Coughlin math or something like that, I think you'll find it. My title is, I think it's Math Geek from Wisconsin or something like that. Whatever. Look at number 4A. 2 over x. Tell me the value of x that you cannot allow. Olivia. What's the value of x you cannot allow on 2 over x? X cannot be what? 0, exactly. Now look at number 4B. 3 over x minus 1. What can you not allow as x that time? Cece. Yeah, you cannot. Here's the problem. 3 over x minus 1. Here we go again. Sorry, people at home. We have 3 over x minus 1. This is number 4B. What value of x can you not allow in this problem? Good. You cannot allow 1. Tell me why not. Yeah. 1 minus 1 is 0. Can't have a total of 0 on the bottom. Okay? So number 4, A, B, C, D, E, F. Try and find any forbidden values of x. I will tell you right now, 2 of them don't have any forbidden values. 2 of them are perfectly fine no matter what you plug in. I won't tell you which 2, but there are 2 of them that are good. Look at number 5. 5G. Does anything reduce? 5G looks like this. X squared over x parentheses x minus 2. Does anything reduce? Max, go. Which x? The one on the outside or the inside?
One on the outside.
Yes. What's stopping you from canceling the one on the inside, Elijah?
subtraction.
The subtraction sign, which is just an addition sign with a mask on it. Yeah, and it'll still bite your face off. So, you tell me, what happens when you cancel x squared and x? What's left? Good. X, on top or on bottom? On the top. Your final answer should be x over x minus 2. That's the answer, by the way, to problem number, I lost what it was, 5G. Everybody feeling okay on this? Okay, the rest of the hour is yours. You don't have a huge amount of time, but you got like 7 minutes, and some of these go pretty fast. So feel free to start pounding away at them. And call me over if you get stuck. I'm going to deactivate the video.